You will see more command with Termux, or in fact it's Linux. We remember Termux. It's a small application that create or simulate a Linux environment. So what you're learning, in fact, it's Linux command. And I'm gonna also show you bash scripting. Interesting thing, that's gonna be your first bash. And I'm gonna show you many more command in using Termux. Interesting things, it's a Figlet, just for your information. If you want to do some ASCII art like I did on the screen, you can install Figlet by pkg install Figlet, like that. And Figlet is already installed on my machine, so there is nothing to do. And you type Figlet my ASCII art. Like that, you can just have your command, and you can play a little bit, having good banners. When you do your script, you can show good banners, information, and then you type in your things, or you can do more. And Figlet is going to do a little bit more than that, so you can search on the internet to see more options about this one. To let you know, in Linux there is special devices and special files, special program file, not program file, but files about what's running on the system. And I'm gonna show you. Let's start with /proc. Let's start with CPU info. When I cat /proc/CPU info, everything go through the screen. I have no time to read anything. I'm gonna pipe in another command called more. You remember when I do cat a file, cat the file, send everything on the standard output. And when I'm doing a pipe, it means the standard output of this command is going to be the standard input of the next one. The next one, instead of reading information from the keyboard, we're gonna read the information from the previous command. That means that every line sent to the standard output will be shown page by page, because this is what more command do. First page, processor 0, and when you look at the information, it gives you information about the processor. So actually, I have processor 0 in that machine. It's an Intel Core i7, 2.2 GHz, and there is a 9 megabyte cache, or so on, something like that. And you have a bunch of information about that CPU. The next CPU number 1, or processor number 1, it's the same kind, and 2 and 3. To give you more Linux command, you can use grep. You remember, everything sent on the standard output will now be sent to grep, and grep will return only lines containing processor. That way I receive only processor 0, 1, 2, and 3. If I want to know how many processor I have in that machine, I can say cat everything, send a standard output to grep. Grep will give me only the line containing the word processor, and instead of sending that to the standard output, I'm going to send that to another command called WC. WC stands for word count. That command counts the number of something depending on the parameters. -L, it means count the number of line you're going to receive. This is why I said 4. I have 4 CPU in that machine. Sometimes you only need to know how many CPU, you don't need the rest. Sometimes you need more information. It depends on what you need. There is another special file, mem info. It gives me a lot of information about my memory, how the memory has been prepared for that machine. I have a total of, let's say, 3 gigabytes of memory, a little bit more. 1.2 is free. Memory available, 2 gig. I have buffers, cache. I have no swap set on that machine actually. And you have a bunch of information about your memory. When I look into proc uptime, it's another one. But the numbers here are not really readable by a human, but there is a command called uptime. The command uptime is going to use those numbers and show me the information more readable for me. Uptime command show me now the when the machine has been booted up. So when I bring the machine up, at what time. And the load average, there is 3 number. You're gonna see that often when you look at performance on Linux or load average. It means how many, what is the load on that machine. A load on a machine means how many resource or how hard the CPU is working. The first number is the average in the last minute. The second number, it's an average on the last 5 minutes. And the third one is the average CPU load within the previous 15 minutes. So this is the way how to read that. If I'm looking into the next one now, proc version, it's a special file that's telling me the version I'm running. Actually, it's a Linux version 4.9. It's Android, and so on and so on. So this is the information about your environment actually you're running. But there is a couple of special proc device like that, or proc a special file I should say. But there is also special device. I'm going into /dev to present you some of those devices. A device, it's the keyboard, the mouse. There's a lot of device, the console, the hard drive, many devices. We're gonna look into it. So there is the CPU, it's a device also. Console, you can see console here. CPU set, full, where I have couple of special devices, another one called a random device. We may play with this one later. Null, you can see null, N-U-L-L. It's a special device. That one I think is this one that we use most of the time. We use null device. I'm going to show you an example. And you have TTY. A TTY, it's the terminal when you log in Linux assign a TTY to you. This is your terminal. We may have many people logged in at the same time. Each one is going to have his own terminal where they type their command line into it. We're going to check later on what terminal we are actually. And you have random, another special device, and 0. It's a special device also. 0. Every time you query this device, it will say 0. Sometimes it's useful. Example: if you want to hide something on your disk, you remove a file, and you know there is tools to recover removed file, because when you remove a file, you just remove the name from the directory table. The data remain on the disk, and maybe you want to put some 0 on that disk, Sometimes we're going to use 0 for that. Sometimes we're going to use random for that. We want to put random numbers. All of this to erase some information. You don't want to. Other people might grab that information. This is useful device for that. Special device. Before that, I'm gonna show you what I prepared today. I prepared 2 things. Wakeup.c. It's gonna be a small C program to wake me up at specific time, hour, minute, and second. And info.sh. That's gonna be our first the first bash script. I call that info. Look into this info.bash. When you start a bash script, the pound sign, it's used to insert a comment. But when there is a pound sign followed by exclamation mark, it's a special directive to tell the operating system this is not an executable file. You need bash to run the rest of the file. So Linux is going to say, oh, okay, I'm going to use bin bash. The bash is in the /bin folder. I'm going to use that, and bash is the interpreter for the rest of my program. This one is a comment. So this is the difference. There is no special character here. I'm going to use a variable. This is the way to use a variable in bash script. You don't have to declare a variable first like we do in C or other language. You just use the variable and equal. You can see I put $. If I put, let's say, NB CPU equal 4, it means NB CPU equal 4. But when I use $, and I put something in between parentheses, it's gonna execute that Linux command, and the result of this Linux command is going to be put in NB CPU. You remember I type in cat/proc/CPU info. I grab everything begin by. I forget to put begin previously, I think. I put processor, but I want to, this is what we call a regex. It's a regular expression. Grep me get regular expression. Grep need a regular expression. A regular expression is something like that. Begin, really at the first column, you should have PROC, nothing before that. Every line beginning by PROC, I want that to be sent on the standard output. And the standard output will be sent to WC command, the word count. That command will count the number of the line, the number of line. The result will be 4. So 4 is going to be put in NB CPU. If I change my virtual machine and I increase the number of CPU, next time I'm going to boot up, I run my script, we say, oh, now you have 8 CPU or 6 or 3. This is the way every time I run my script, I have a fresh understanding of the number of CPU I have. Uptime, it will take only the result of uptime, including the load average. And OS, you remember when I cat/proc/version, I will send that to Hawk. Hawk, it's a program. When he receives information, is going to print the first item, the second, and the third one. If you remember, it was Linux 4.4 point something, I don't remember exactly, and so on, and Android, something like that. I just need the 3 first. Awk is going to send me the 3 first item. Is going to put that in OS. or I'm not just only fetching the information. Now I'm going to display this information. This is my report. Here is your machine information. Your operating system is the operating system. Server up since uptime, and the number of CPU core and number of CPU. The way of doing this, running this, you remember if I type info.sh, it doesn't work because of my path variable. I explained that in the previous Termux demonstration. I will run it that way. Dot slash mean the dot mean the current folder where I am, the info.sh right there, and it's telling me this is your machine information, this is your operating system, the server is up since the load average in the last minute, 5 minutes or 15 minutes, and you have 4 CPU core. So I don't have to retype all the command all the time. Now I have a script. The script is giving me the information I need in a fraction of a second. This is how you're gonna script your first bash. Eventually you're gonna do more complex things. Let's try one. You can put some if here. If, let's say, NB CPU greater or equal to, then equal mini CPU, else think about adding more CPU. And phi to say my if is finished. Let's try to run this one. And now I have your operating system, number of CPU 4, and it says right after mini CPU, because I said if it's greater or equal to 2, I have many CPU. But now let's say 8. If number of CPU is greater, or I need at least 8 CPU, I'm gonna run that again. Is to think about adding more CPU. Adding, I just made a mistake, put another D. Now it's better like that. Now it's telling me think about adding more CPU. You can script like that. You gather information, you check if information is greater, lower, and then you can take action. This is the way it works. You now have your first bash. For sure, it's only a first bash. Eventually, I'm gonna show you more about bash. But the most important before doing bash script is to really know how Linux works. What are the commands? Especially you don't know the yes command. There is a command called yes. Every time you run that command, it's giving you yes. You just say yes. You know that command seems not really important, but sometimes to do automation, it's gonna be really useful, that kind of command. And you need to learn a lot of command before thinking doing some bash script, because a bash script, it's running bunch of command and doing a program. It's programming. But before that, you need to gather a lot of knowledge about Linux. That's what I'm giving you right now. Let's check another command that I like. It's octal dump. You remember that info.sh look like that, but we can look in octal dump -c or -oc my info.sh. Octal dump is just showing me the file in octal numbers, and under, because I put OC parameters, I also see the character. So you saw the pound sign, the exclamation mark, the /bin/bash, \n is because after bash I press enter twice, and then I start a comment, and my comment was fetching information and a couple of dash until I press enter again, and then I type nb_cpu and so on. So this is useful when you have it happens sometimes when you work in IT. People will call you and said, my program is not working. Everything looked fine when we looked at it with our eyes, but when we look with octaldump, we might see some unprintable character or control character, sometimes insert in the code. And when we see that on a print screen, it look fine. But when you see it with octaldump, you can see control character. This is why I want you to know about octaldump and the way to work with it. It's a good information to know. We start with DD command. I'm gonna explain you that after. DD stand for device dump or dump device. Dump device is going to query a device and dump that on the standard output, or if I give him a specific file name, I'm going to put that in that file name. I'm going to use input file. My input file is my special device called /dev/u random. My output file is going to be my file. Block size will be 1K and count equal 5. That means I'm going to dump that device, a device called /dev/u random. I'm going to use a buffer of 1K, and because I'm going to doing that 5 times, I'm going to fill up my buffer. I'm going to put that in my file. I'm going to fill it up again 1K at a time until I reach 5 block of 5K. If I'm looking in this now, I have my file. It's a 5K. But if I'm doing VI of my file, there's a bunch of characters, and many of them are non-printable. If I use octaldump to see the file, I can see I have random numbers over there. So it's all random. When I tell you about another special file called 0 /dev/0, I'm going to query now. Now if I'm doing octaldump of this file, that file contains only zeros for 5K of zeros. And when you see a star on the beginning of the line, it means that it did not repeat that line, because it's repeat until that line number. It means till the end, because there is only zeros in it. From beginning to the end, there is only zeros, because that special device is giving me 0 every time I query it. And another device I told you, I'm going to write this. This information is sent to my screen. I will say hello world. It's always a good hello world is sent to my screen, but I can send that to /dev/null. When I send that in /dev/null, it means that I don't really care about the output of this command. You can discard that information. This is what this means. Sometimes we do that often. We run something in the background. We don't really care about the output of it. We know the output. There is no human behind the keyboard. It's a running process. Don't bother me with the output. Send that to /dev/null. Just discard that information. So this is a special device we use for that. Another one is TTY. I told you that we have a TTY every time we get on a machine. So this is another one. I can say hello, and I can send hello to /dev/pts0. And because I'm connected to that device, I receive it on my screen. This is why I receive it on my screen. I can send that also to /dev/console. /dev permission denied. Okay, I don't have permission because I'm not root. We're gonna work with root later when you're gonna be more experimented. Now everything I do it as a normal user. Eventually you're gonna see root can do a little bit more than a standard user. So we're gonna see that in another video when you're gonna be root mean a super user. You're no longer a normal user. You're a super user on the machine, and I'm gonna teach you how to become a super user and do more things with Linux. So that's it for this one. Okay, we're gonna see that I prepare another exercise. The other one I call it wake up. With that wake up program, I'll be able to show you more on Linux also. Let's see what wake up program is doing. I include a standard input output. I input times because I will need, by the way, it's a wake up call program. I just do a program to wake me up at a specific time, hour, minute, second. Uni std, it's another library because I'm going to use a sleep command, and sleep is part of it. And standard bool, because I'm using a boolean in my program. Standard bool include definition of true and false. It's useful to play with boolean. This is my boolean program, function, sorry. I did a function check time. Check time, it's a function. I'm going to give him hour, minute, and second. And this check time is going to return to me if the current time is equal to this time. Is it true or false? I just want to know if I say wake up at 7 o'clock, 0 minute, 0 second, you're gonna check, okay, are we 7 o'clock? No, false. Okay, let's wait. You're gonna check again. Are we 7 o'clock? No. Okay, that's false. Okay, we're gonna wait a little bit more. And then at 7 o'clock, we say, oh, yes, it's true. It's 7 o'clock now. You're gonna return true that it's 7 o'clock. For that, I need some time information and my flag. Initialize the time with my local time. I'm gonna print on the screen. It's actually that time. I start with my flags equal false, and then I check is the local time hour is equal to the hour I want to wake up. If it's the same hour, is it the same minute? If it's the same hour and same minute, is it the same second? If it is, it's true. It's time to wake up. I'm going to return false most of the time, but at the specific hour, minute, and second, I'm going to return true. This is the main program. Main program, I'm going to receive argument count and some argument variable. Those argument variable, the first one, when I'm going to launch my program, the first argument will be the hour I want to wake up, then the minute, and then the second. All of those arguments is going to convert from ASCII to integer, and that integer will be stored in a hint variable. ASCII to integer, the integer is going to be put in M and S for second. The first output I'm going to show to the user is, okay, sir, I'll wake you up at that hour, minute, second. You saw before, maybe when you learn program in C, before the first place here in the 4, it's usually counter equals 0. In fact, it's the statement you need to do before the loop start. In my case, there are nothing specific to do. And here, it's usually counter plus plus. But in my case, there's nothing special to do. And here is sometimes it's when counter is lower or equal to 10. But in my case, it's true because it's we call that an infinite loop. It will be always true. It's an infinite loop I'm doing. My wake up machine is running until I shut down the computer. It's running all the time. And it's just checking every time it's 7 o'clock. It's going to say, okay, wake up. It's time to get out of the bed. And that's all. And then it's going to wait for the tomorrow. And tomorrow is going to say, hey, it's 7 o'clock. Wake up. It's time to get out of the bed. And so on. And when it's not the time to get out of the bed, or it is, after that is going to sleep 1 second before checking again. If it's not the proper time, he's going to wait 1 second and then he's going to check again. He check every second like that until we reach the proper time to wake up the person. And then we return 0 to exit normally, but we're gonna never exit from this. Compile that, and I try that. Wake up 7:00. You know it's running every second like that. It's midnight 6 minutes right now, and so on. I won't go wait until 7 o'clock because it's going to be too long for that. I will say, okay, wake me up at 0, 7, and 10 seconds. And I say, okay, wake up. It's time to get out of the bed because we reach the proper time. This is the way to do that. What I'm going to show you with this is, let's imagine it's really a well-designed, actually it's not really well-designed because it's written on the screen that won't really wake me up. Eventually you're going to do that playing a sound or something like that. And maybe the ability to snooze or to stop, a better application. But for now, let's imagine this is a wake up and I want to execute that. But I want my keyboard, I want to use my keyboard again to do something else. I can do Control Z, and now the job is not killed. It's just put on pause, on hold. Just put on hold. If I'm doing jobs -L, this is my running job actually, and that job is just sleep. It's on hold. It's not running. It's still in memory. But nothing happened, no longer checking. If I'm sending that in background, now the job is running in background, and now I have again my command line to do something. But what is not interesting here is the job is running in background and sending information to the screen. It's not really funny for me to try to go in a file. And when I'm in my program, things happen like that in the screen. It won't be really useful. So what can I do? I do job -L again, and then I can bring it back in foreground. Now I'm going to type FG foreground %1. My job has been brought back in foreground mode. I can do Control Z again. Now it has been stopped and it stopped bothering me now. I can also kill %1 and now the job is terminated. Now if I'm doing jobs -L, there is no more job because I didn't send it properly, because the output is going on the screen. Let's do it again, but this time I'm gonna send the standard output to /dev/null. I'm gonna send the standard error at the same place of my standard output, and I'm gonna launch that, okay, like this, and I'm gonna do Control Z and BG to send this in background. Now it's no longer bothering me, and if I look at, my job is running, so that's fine. I can send another one that will wake me up at 7 o'clock tomorrow morning. Control Z again. I can have another one because I'm gonna sleep a little bit more near 4 o'clock, and I want just to sleep an hour. I want you to wake me up at 7:17 or 17:15. Control Z again. My job is there. So you know I have many jobs. The one of them is running, the other are not running. I'm gonna send the job number 2 in the background, and I'm gonna send the job number 3 in the background. Jobs minus L. Now I have 3 jobs running. One of them is going to wake me up at midnight, 7 minutes 10 seconds. The other one is gonna tell me at 7 o'clock, and the other one at 17:15 is gonna wake me up again. So I can have a mini alert like that. I can say, okay, I have to remember to bring 1 liter of milk after my job, so send me an alarm at that specific time. You can play like that. If I'm looking to PSAIX and I grep wake up, grep wake up, we can see my job are running. And you remember I do Control Z. How come I know it's Control Z? There is a command called STTY. You can do it -A to have all. -A mean all, everything. TTY, you remember, TTY is the terminal I'm using actually. STTY is the setup of that terminal. A terminal works like a modem. If maybe some of you are too young, never use a modem or a DOME terminal, but it's using speed like the baud rate. Baud is it's a unit of measure of a speed, how many bits per second are transferred. There is the actual terminal I have 27 row, 84 column. This is a definition like that. Control C. When I'm doing a command and I do like top, I'm going to show you now the top command. Top is giving me the top process running, and it's refreshing like that every, let's say, 1 second or 2. That is giving me how many tasks running, how many memory usage, what is the top process running actually. When I want to get out of this, I do Control C. By doing Control C, I'm back. And why I know it's Control C? Because Control C send an interruption. So it's like doing a break that. Quit, erase. In fact, it's only the backspace. Kill U, it's when you type. Erase is the backspace, but Control U to kill is gonna erase everything you did. Quit could be interesting in some application that we don't have right now. End of file. When I said read in a variable, is going to read until it reach the end of file. If I'm typing Control D, it simulates a end of file. So the read is now done. If I'm doing echo df g df, echo, there is nothing because I didn't put anything. I just Control D to get out. And then after that you have start stop, control Q and control S. Control Q, control S is going to stop everything going on the screen, and control Q to start again. And the control Z, here it is, suspend. When you send control Z, it suspend the actual program. Like I can do find slash, and then I do control Z. The program has been stopped. I bring it back in foreground. It's continuing, control C. I kill it, now it's no longer running. This is the kind of thing. The rest is like modem configuration, parity enable, parity odd, character size, hang up process on carrier lost. The HUPCL could be interesting. When there is a minus, it's like it's disabled. But if there is no minus, every time you lose your session, every background process is going to receive a hang up signal. By the way, the signals, if I'm doing jobs -L, I can send signal -15 to my PID 717067. My job is now terminated because signal 15 is sending a signal to this PID. The process was running, but I tell my process, okay, stop that please. Now I have only 2 jobs running because one of them has been killed. This is the way to stop a job. Another way is to bring it back in foreground and control C on it. So you know a bunch of things now. How you interact with your keyboard, you better know your keyboard now with the control C, control Z, things like that. You know special proc files to know more about your memory information, CPUs. You know more about some special device to receive zeros, the command yes, you wake up, you have your first bash. I hope that gives you good information to have a better understanding of what you can do with Linux and what you can do with your bash. And I hope you enjoy. Have a good evening and see you soon. Thank you again. Bye bye.